Have you ever looked up at the night sky and wondered, how did all this come into being? The twinkling stars, the vastness of space, the intricate cosmic structures. How did they all come into existence? What colossal event could have possibly triggered the creation of the universe? Well, the answer to these intriguing questions lies in the realm of cosmology, the study of the universe's origin and evolution. Among various theories and hypotheses, the Big Bang Theory stands tall as the most widely accepted cosmological model. It provides us with a comprehensive framework that explains not only the birth of the universe, but also its evolution over an astonishing 13.8 billion years. Imagine this. The universe, in its earliest form, was an infinitesimally small, hot, and dense point, known as a singularity. Then, in a cataclysmic explosion of unimaginable scale, this singularity expanded, giving birth to all the matter and energy that make up the cosmos we see today. But the universe didn't just spring into existence in its current form. It evolved over billions of years. As it expanded, it cooled down, and the chaotic plasma of particles began to form structures. Elementary particles combined to form atoms, atoms assembled into molecules, and these molecules eventually coalesced to form stars, galaxies, and all the cosmic structures that decorate our night sky. It's a fascinating journey, isn't it? The path from a singularity to the diverse and expansive universe we inhabit today. This journey, and the processes that shaped the cosmos, is what the Big Bang Theory aims to elucidate. The Big Bang Theory has not just revolutionized our understanding of the universe's origin and evolution, but it has also posed intriguing questions about its future. Will the universe continue to expand indefinitely, or will it eventually contract? These are questions that continue to fuel scientific exploration and debate. In the next few minutes, we will journey back to the beginning of time, to the very moment our universe was born. We will explore the fascinating story of cosmic evolution as told by the Big Bang Theory, a story that continues to unfold even as you watch the stars twinkle in the night sky. Imagine, if you can, a moment when all that exists was condensed into a single, infinitely dense point. This point, known as a singularity, was the birthplace of our universe and the cradle of all matter and energy. In the realm of cosmology, a singularity represents an extreme state of the universe, where the laws of physics as we understand them break down. The singularity at the dawn of the universe was infinitely hot, infinitely dense, and infinitely small. It was a point where space and time, as we understand them today, didn't exist. Then, about 13.8 billion years ago, a monumental event occurred. This singularity exploded in a cataclysmic event known as the Big Bang. This was not an explosion in the typical sense, occurring within space and time. Rather, it was an explosion of space and time. The Big Bang was not something that happened somewhere. It happened everywhere. In the blink of an eye, the universe expanded from that tiny singularity to an unimaginably large size. All the matter and energy that make up the cosmos today were created in this event. It was a moment of creation, a moment of birth for everything we know and see around us. Initially, the universe was a hot, dense, seething soup of particles. It was a plasma so dense that light couldn't travel through it. As the universe expanded, it began to cool down. Particles started to combine to form atoms, and as the universe continued to cool and expand, these atoms could come together to form molecules, and ultimately, the stars and galaxies we see today. The Big Bang was the starting point of an epic journey. From that initial singularity, the universe began to evolve, to grow, and to take shape. It was the beginning of time, space, matter, and energy. It was the beginning of the cosmic story. From this fiery birth, the universe began its epic evolution. From a tiny, dense point, the universe has expanded and evolved into the vast, diverse cosmos we see today. And it continues to evolve, to change, and to surprise us with its complexity and beauty. As the universe expanded, it cooled, and matter began to take shape. Picture the universe as a cosmic kitchen, and the ingredients are elementary particles. These particles, including protons, neutrons, and electrons, are the building blocks of all matter. As temperatures dropped, these elementary particles began to combine in a process called nucleosynthesis, forming the first atoms, primarily of hydrogen and helium. These atoms weren't content to stay solitary, however. As the universe continued its relentless expansion, these atoms began to band together, forming molecules. The universe was becoming more complex, more diverse. It was beginning to look a little bit more like the universe we know today. Now enter gravity, the great organizer of the cosmos. Gravity began to pull these molecules together, creating massive clouds of gas. These clouds grew denser and denser until, under their own weight, they collapsed. And in these moments of colossal collapse, stars were born. These stars, burning bright and hot, were the first sources of light in the universe. But the universe wasn't done cooking yet. The stars, drawn together by gravity, began to form galaxies. These galaxies, each with billions of stars, formed the backbone of the cosmic structures we see today. And within these galaxies, planets, asteroids, and comets took shape, forming solar systems. However, the universe didn't stop there. Galaxies, in their turn, were drawn together into clusters, and these clusters into superclusters. These large-scale structures, interconnected by cosmic webs of dark matter, make up the large-scale structure of the universe. So, from a hot, dense point, the universe expanded and cooled, and matter began to form. Elementary particles combined to form atoms, and atoms assembled into molecules, then into stars, galaxies, and cosmic structures. Each step, from the smallest particle to the largest supercluster, was crucial in the universe's journey from a singularity to the vast, diverse cosmos we see today. And remember, this wasn't a process that happened overnight. We're talking billions of years, each moment a crucial stitch in the tapestry of the cosmos. This process created the vast, diverse universe we see today. But how do we know all this? What evidence do we have for the Big Bang, one might wonder? Well, the answer lies in the cosmos itself. The cosmic microwave background, or CMB, provides compelling evidence for the Big Bang theory. Discovered in the mid-20th century, the CMB is a faint afterglow of the hot, dense early universe. Today it's observed as microwave radiation that permeates the cosmos. This radiation is a relic from the universe's infancy, a whisper from an era when the universe was a dense, opaque plasma of particles. But the CMB isn't the only piece of evidence supporting the Big Bang theory. The theory also made several key predictions about the universe that have been confirmed by observations and experiments. For starters, the Big Bang theory predicted the abundance of light elements. It suggested that in the early universe, conditions would have favored the formation of hydrogen and helium over heavier elements. And indeed, when we look at the cosmos today, we find that hydrogen and helium are by far the most common elements, making up roughly 98% of the observable universe. The theory also predicted the cosmic redshift of galaxies. This is the phenomenon where light from distant galaxies appears to be stretched out, making it look redder than it should be. This redshift is a direct result of the universe's expansion, just as the Big Bang theory proposed. Lastly, the Big Bang theory predicted the large-scale structure of the universe. It suggested that the universe on a grand scale would look the same in all directions. And when we look out into the cosmos, that's exactly what we see. The universe's large-scale structure is homogeneous and isotropic, meaning it's roughly the same no matter where we look or what direction we look in. All these observations and experiments have bolstered the credibility of the Big Bang theory. So, when we gaze up at the night sky, we're not just seeing stars and galaxies. We're seeing the fingerprints of the universe's explosive birth. The Big Bang theory doesn't just look back, it also looks forward. It gazes into the future, contemplating the ongoing expansion of the universe. This expansion is not a static process, but an active, dynamic one, a concept known as cosmic inflation. It's a grand symphony of celestial bodies moving apart, creating an ever-growing cosmic canvas. But the question that looms large in our minds is, what's the ultimate fate of the universe? This is a topic that sparks intense debate and speculation among the scientific community. Some propose a never-ending expansion, with galaxies drifting further apart until the universe becomes a cold, dark, and desolate expanse. Others suggest a more dramatic end, a big crunch where the universe's expansion slows, stops, and reverses, leading to a cosmic contraction. Whether our universe will expand indefinitely or eventually contract is a mystery still waiting to be solved. Whatever the outcome, it's a fascinating journey of discovery that awaits us. The Big Bang theory has profoundly transformed our understanding of the cosmos. A beacon in the realm of scientific investigations, it has ignited the spark for numerous groundbreaking discoveries. The theory's elegant explanation of the universe's birth and evolution has paved the way for advancements in astrophysics, quantum mechanics, and cosmology. It has fueled research into the mysterious dark matter and dark energy, components we know exist but have yet to fully understand. Beyond the scientific sphere, the Big Bang Theory has made a significant impact on public imagination. Its fascinating narrative has permeated literature, cinema, and art, inspiring a multitude of creative expressions. It has become a cornerstone of our cultural heritage, a shared story of our cosmic origins. The influence of this theory extends far beyond the confines of our planet. It has rendered us aware of our humble place in the grand cosmic tapestry, amidst galaxies, stars, and nebulae. This theory has forever changed our perception of the cosmos and our place within it.